In this video, we're going to look at an extension to ANOVA hypothesis. When we reject an ANOVA null hypothesis, we can only conclude that all the means are not the same. At least one mean mu is different from the others. But which one is different and which pairs are different is something that we need to analyze further. And this is done through what is called Fisher's least significant difference, and shortened LSD. Now, pairwise hypothesis is what we test with LSD, and that is, you take any pair of means. The null hypothesis is that the pair of means are equal and they are not equal is the alternative. Now, to test this hypothesis, we use the absolute difference between the corresponding sample means, x bar sub I minus x bar sub j, and if this absolute difference is large enough, okay, in other words, is it larger than the least significant difference? If it is larger than LSD, then we reject the null hypothesis, otherwise we do not. And the formula for LSD is the t-table value times square root of MSE multiplied by 1 over n sub I for the sample I and plus 1 over n sub j. And the degrees of freedom for finding the t-table value comes from MSE. We can also construct confidence interval for mu sub I minus mu sub j by simply taking the difference in the sample means and using LSD as the margin of error. One more concept that we have to be aware of is called Bonferroni adjustment, and that is when we do a number of pairwise tests, the level of significance alpha will get deteriorated. So when we are doing multiple sets of hypothesis tests, then we really need to change alpha. So the alpha we need to use is you take the overall experiment-wise alpha and divide by the number of pairwise comparisons that we need to make. Like if you want 5% overall alpha level, and you take 0.05 and divide by the number of comparisons that you have to make, and that is the alpha we have to use to determine the t-table value. In the next video, we look at Fisher's LSD for the last problem that we did in Excel, and that was the assembly method, productivity for the 3 assembly methods.